Welcome, ladies and gentlemen, to the Networking Guide channel. My name is Dylan Lane, and today we're going to be doing part one of our two-part series on VLANs. In this video, we're going to dive deep into VLANs, specifically talk about what are LANs, what are VLANs, what they do, the different types of VLANs, as well as covering the concepts I'll be demonstrating and configuring in part two of this video, which are VTP or VLAN trunking protocols, extended VLANs, as well as dynamic trunking ports or DDP. So without further ado, let's begin. Local area networks or LANs. Local area networks or LANs can simply be defined as networks consisting of computer devices that are interconnected or physically connected to the same area of building. This can occur in universities, laboratories, offices, and they're referred to as single broadcast domains. Now, what do we mean by single broadcast domain? This means that if a network administrator or a user decides to broadcast information, whether it be configurations, happening on a switch or router, or any updates or changes on the LAN, this means that the broadcast is going to be received by all their users on that LAN. So moving forward, virtual local area networks or VLANs. Virtual local area networks or VLANs are, as the name hints, virtual networks that consist of groups of computer devices from one or more local area networks that are combined into one singular logical network. This process is able to happen because the VLANs are able to segment the local area networks into various and different broadcast domains. And many of you might be wondering what's the purpose of virtual local area networks or VLANs. Well, in my next slide, we'll go more in depth on that. I'll explain briefly now. Virtual local area networks or VLANs allow groups of computer devices such as Cisco switches and large organizations such as Amazon and Google the ability to communicate with one another even though they're not physically connected with one another. However, let's continue to move forward so I can go into greater detail as to what VLANs do. Other functions VLANs can provide for a network are the ability to filter broadcast traffic, provide network segmentation, help mitigate network congestion, as well as perform address mitigation. While these are just a few of the many ways VLANs can be implemented and utilized in a network, they all kind of tie into the same benefits, which all go hand in hand with one another. So when a network administrator segments a large network consisting of different LANs into smaller VLANs, they're helping, as you can clearly see right there, filter broadcast traffic and helping reduce the amount of broadcast traffic in turn because each broadcast is only going to be sent on a most relative VLAN only. Next benefit of segmenting large networks into smaller VLANs is it helps reduce the cost. Because instead of creating a routed network consisting of routers, we're able to use switches, and in the world, switches are a lot less costly than routers, which also ties into the next benefit, which is the reduced need of routers on a network, which also ties into the first benefit, which is broadcast control, because less routers equals less broadcast traffic. Moving on, the next benefit to using VLANs is increased security of a network. There will be multiple broadcast domains. The network administrator will be able to have control over each port, as well as what resources the user can access on those ports. In addition, VLANs help make it easier to help restrict vulnerability traffic originating from the organization or company. This leads us to our second last benefit, which is simplified administration. Since the networks are all connected through the VLAN, the network administrator doesn't have to go to each network and apply the same configurations, the same information. He can just do it once on a VLAN and broadcast it to the others. So this makes it a lot easier for network administrator's job. It helps ease them, as it simply says, which all these methods lead to increased performance in the organization because there's a lot less time and resources spent on materials that can be done once instead of multiple times. Now that we know what LANs are, what VLANs are, and what to do, as well as some of the aspects and benefits, it's time to know the two types of VLANs. And the two types of VLANs are either static VLANs or dynamic VLANs. And I'm sure everyone here knows that when you hear the word static, you know you got to assign something manually. And in the case of static VLANs, this is still true. In static VLANs, we have to manually assign switch ports needed for the broadcast domain. And in addition, any device that happens to be connected to the switch ports when it's configuring a static VLAN automatically becomes part of that specific VLAN. However, with dynamic VLANs, as I'm sure you all know means automatically, they are automatically assigned dependent upon the MAC address. In other words, this means that client machines will stay in the same VLAN no matter which switch port they are assigned or configured to. Now that we have covered the basics of VLANs, including what are LANs, what are VLANs and what they do, the different aspects and benefits, as well as the different types, we can finally move on to what I'll be demonstrating in part two, which are VTP, extended VLANs, and DDP. VTP or VLAN trunking protocol is what allows network administrators the ability for Cisco switches to exchange VLAN information. This is possible because the protocol has the network administrators only create the VLAN required on one single, and the switch broadcasts or propagates the information and configurations about the VLAN to all the other switches in the network. Another fact I found interesting about VTP is that it stores all the VLAN configurations information in the VLAN.dat database. I'm not sure if anyone's going to be entering a field where you have to configure VLANs as well as implement VTP. However, I thought it was an interesting fact nonetheless. Moving on, a switch can be configured in any of the three VTP modes, which are VTP server, VTP client, as well as VTP transfer. If a switch is configured as a VTP server, the user will be able to create, modify, and even delete VLAN configuration, as well as advertise the VLAN configuration to other switches on the same VTP domain, and even synchronize the VLAN switches depending upon their advertisement over trunk links. If a switch is configured as a VTP client, the user can do the same as the server. However, they're not capable of changing, creating, or deleting VLANs on a VTP client. If a switch is configured as a VTP transparent, the only thing the user can do is transmit VTP advertisements that are received upon the trunk ports of the switch. Speaking of advertisements, now that we know the VTP modes, we must also know the VTP advertisements as well. There are three types of VTP advertisements, which are summary advertisements, advertisement requests, and subset advertisements. Summary advertisements are sent every 5 minutes in regards to the revision. Revision number is a 32-bit number that helps indicate the level of revision in a VTP packet. So if the revision number happens to be higher than the one we currently set for the VLAN or switch, then the summary advertisement is sent. Advertisement requests are quite simply requests made from client servers to client switches in regards to VLAN information, whether it be configurations or so forth. And last we come to subset advertisements. Subset advertisements are simply advertisements sent with general VLAN regarding any configuration changes or just changes in general made. Extended VLANs. Extended VLANs are mainly used by big network service providers such as Xfinity and Verizon to allow the provisioning for many customers. Now, what that means is they want to have extended VLANs so they can provide a wide range of customer service. Now, before we can configure extended VLANs, there are some requirements that have to be met. The first is that extended VLANs have to be configured on switches that are only set to VTP transparent mode only. In addition, extended VLANs, this goes without saying, have to be configured in configuration mode only, not VLAN database mode. And lastly, when configuring extended VLANs, you have to set them within the range of 1006 to 4090. Otherwise, they are not extended VLANs. And lastly, we come to the last concept that I'll be demonstrating in part 2 of this video, which is dynamic trunking protocol. DTP or dynamic trunking protocol is a trunking protocol used exclusively by Cisco switches to automatically assign trunk ports between two VLAN switches in a domain. In other words, DTP is used to negotiate trunking on a link between two VLAN switches. In addition, dynamic trunking protocol or DTP can also assign a calculation type for VLAN switches, including the most common being IEEE 802.1q or Cisco ISL. And a little fun fact I want to put in there was that dynamic trunking protocol or DTP is accomplished in layer 2 of the OSI model. In conclusion, VLANs are quite simply groups of computer devices from different networks that are combined into one singular logical network for the sole purpose of being able to communicate as if they are on a local area network or a LAN. VLANs are utilized to help filter broadcast traffic, provide network segmentation, as well as perform address summarization, which in the long run for a company that reduce the cost of the network, increase the security network, help ease the network administrator's job, which overall leads into the main benefit of VLANs, which is increases the overall performance in an organization. And there are two types of VLANs. Static VLANs, which require network administrators to manually assign switch ports to the switch, and dynamic VLANs, which network administrators don't really have to touch at all, because network VLANs automatically assign their switch ports based upon the MAC address of the VTP or VLAN trunking protocol is what allows network administrators the ability to not only exchange VLAN information, but be able to set up a VLAN on one switch that broadcasts the VLAN configuration all switches on the VTP domain. As mentioned earlier, there are three VTP modes that switches can be configured to, which are either VTP server, in which the network administrator will be able to create, modify, or delete any VLAN configurations, as well as synchronize or broadcast the VLAN configurations. VTP client, which can do everything a VTP server can except create, modify, or delete VLAN configurations. And VTP transparent configured only transmits advertisements that are received in the trunk ports on the switches in the VTP domain. In addition, we also discussed extended VLANs, which are mainly used by big network services to allow plenty of provision for their customers to provide the best customer service. It's also important to note that when a network administrator in a large company or organization wants to add extended VLANs to their network, they have to configure extended VLAN on a switch that's configured in transparent mode, as well as be set in a range between 1006 to 4094. And lastly, as we just touched on the last slide, dynamic trunking protocols, or DDP, are utilized to either automatically assign trunk port routine to VLAN switch or assign the encapsulation type to the switch, which are either the most common being IEE 802.1Q or Cisco ISL. I just want to take this time to thank everyone for their time and attention throughout this presentation. Now that we have more knowledge in regards to VLANs, we can move on to the demonstration video that I'll be doing in part 2 of my 2-part series on VLANs. I look forward to seeing you guys there. This is the Networking Guy signing off.